Okay, now we're running into units problems here because it's going to turn out that A and B, as you can even see from these two equations, are going to have different units, and it's totally incompatible. Okay? When we solve for A, we go through solution, and it's very straightforward. We end up with B equals this, but A, of course, has to equal B over RC. RC has units. Okay? So the units of A can't be equal to the units of B, but the units of A and the units of B have to be equal. Okay? If they weren't, you wouldn't be able to add these two. So I'm going to repair that by throwing in an omega here, which I was inclined to do originally. And this is like you're driving a circuit with a capacitor and a resistor with an alternating current. Okay? So we really have to consider the units of T. When you look down here, you understand that the units of this quantity should equal the units of this quantity, but the units of this quantity really should have units of time. When you take the derivative with respect to time of a cosine, the chain rule gives you units of time out in front. Well, we take care of that by using an omega. Okay? I think. I mean, this is better work. Okay, so what we're going to do is we're going to insert an omega. Now, I don't have a lot of room, don't want to rewrite all this, so I'm going to just throw a tiny blue omega in here. And when you see the blue blob, that omega came out readable, that one didn't. Limitations of this particular chalk on this particular board. And limitations of space. So I've got a bunch of omegas in here, right? Now, when I take the derivative, I'm going to have not a negative a sine of omega t, but a negative omega a. And I can write that omega big enough that you can almost read it. Okay? And then if I smudge out this plus sign, I'm going to have an omega here. Okay? Which gives me what? An omega on this B and an omega on this negative A. Okay? Now my units are compatible because omega has units of reciprocal seconds. And I have now units of reciprocal seconds here. So my equations here become omega B plus A over RC and negative omega A plus B over RC. Okay? So that A equals B over omega RC, right? And I hope this is going to work. This means then that if I plug this into this equation, I get I've got my B over RC, and my A gets replaced. No, I solved this one for A, so I'm plugging into this one. Okay, so I've got omega B here plus A over RC. So that would become omega B plus A over RC. This would be B over.
So shouldn't omega RC be squared again?
Omega times RC squared. Okay? And the units, if you think in terms of seconds, that's reciprocal seconds. Okay? And when you divide the second squared here by the reciprocal second, you get reciprocal second on this, and that repairs the units. Okay? Then over here, when you solve this, just trying to figure out how to put things in here. It's like you get omega B, right, times 1 over omega RC squared, okay? So you're going to have an omega here and an omega here. And when you solve for B, then you're going to get a reciprocal. Well, you're going to get an. Wait a minute. You're going to get this. You're going to have like an omega here, and then you're going to have reciprocal omega. So it's like you're going to have an omega. Well, I better write it out.
I was gonna say, it would be like a omega times 1 plus omega RC squared, right?
Yeah, like that. I just can't figure out how to write it in there.
Right.